Hello, students. In these sessions, we will learn about console I/O. We have very briefly studied about console I/O on week 2. Today, we will have more closer look at console I/O. In addition to that, we will talk about the file input-output in the following sessions. So let's start. So let's quickly revise basic stuffs we learned on week 2. For console I/O, we have been using cin and cout. You have been using this cin and cout quite a lot of times for weekly assignments, so I'm sure that by now you are familiar with them. To use them, you have to include I/O stream library and declare the standard namespace like this. So this is not new stuffs. You've been using this for your weekly assignments. And we can send out the data from the program using output stream, and which is a cout here. Out can be used with variable, constants, literals, or even expressions. And this is called the insertion operator. We use insertion operator with cout objects. For input, we use different operator, which is an extractor operator. They are two different operators. The extraction operator points the opposite directions. And we can use two variables in one cout. So if you look at here, this one and this one is variables. We can use multiple variables and values in one cout statement. And I have already explained this escape sequence before. This \n is an escape sequence, and C++ interpreted it as a new line. And even C interpret this as a new line as well. And L is also resolved to new line. So you can use whether this \n or endl for new line when you are putting output data to the console. So it's the same result here. And you can also format output. By default, the value may not display as you expected. For example, if the price is a variable, if this price is a double type variable, and if it is set to 78.5, you might get this number or this number on your console. If you put this string to the console, you might get this result or this result. So these two format may not be the your expected result. So you have to explicitly tell C++ how to output numbers in your program. For that, you use a magic formula, which first decimal size. So if you put this formula, these three statements, before using cout to output data to console, you will get a result that numbers are printed as exactly 2 digits after the decimal point. So this cout statement will produce this output, 78.50. For now, just remember this like you remember math formula. I will revisit this when we are discussing class and member functions. Note that if you change this number, for example, if you change this 2 to 3, you will have a number with 3 digits after the decimal place. So let's look at this using demo code. Okay, so see out. I think there's no demo code, so let me create this one. See out one.cc file. If I print it. Okay, this is the code we have seen in the slides. So if I disable this part of statement, which we called magic number, and if I compile this program, so as you can see here, price is a double type of variable and it holds this number. And when we print this price, the program prints this 4 digits after the decimal points. So it did not print this part. So if you want to force this program to print 3 digits only, all you need to do is set this one to 3. So if I compile again, if I do it, now it prints 3 digits. And if I change this to 2, now it prints the 2 digits after the decimal point. So like this, you can formatting the output. Let's go back to the slides. Okay, so for console input, we use scene object. When you use scene, we use extraction operator, this one. It's opposite directions to the insertion operator we use for the cout. And no literals are allowed when we are using the scene and extraction operator. So you must use variable. So like this, num is a variable. You must put variable here. You cannot put literal here. So if the program meets these statements, it waits for the keyboard input from the users. And once the keyboard value is entered, it reads the value and assigns the value to given variable, which is a num here. So if you put A through the keyboard, the A will store here. So this is not new stuff. You've been using this for your weekly assignments. And you can keep output and inputs on the same line. If you omit the new line at the end of the last cout. So here, there's no new line. Escapes the cons or \n or endl. So if you omit this new line, then the user's input will appear on the same line as prompt. So if you program like this, the user's keyboard value will be appear here. So this makes better interface for users. So user can type the data here. And we have learned string class. You can also use string class to store input data, just like other types. And you can use more than one variable in a single cin statement. So this this. So these three are all equivalent. You can separate cin using semicolon like this, or you can put in one line like this, or you can put two lines but without the semicolon here. So this result same consequence. And when program reaches a cin statement here or here, it waits for the input from the keyboard. And when the input is entered, it reads the input data until it meets the white space. So that is the key. Cin reads the data until it meets the white space. Again, cin read the input data until it meets the white space. So first value type at the keyboard will be stored in the first variable, in this example S1, and the second value will be stored in S2. And cin does not read the inputs until user press the return key. So it waits here for user input until user press the return key, which is an enter. So this allows the user to backspace and correct mistakes when they are entering a line of inputs. And one thing to remember is that when you use cin statements, it skips over any number of white space. So it's also very important. It skips over any number of white space. So this means that you cannot store the inputs that contain space. Let's say if program reads input using these three statements, if user type this, may the hair on your toes grows long in curly string, S1 read, so this cin read this string and stores the value may to this S1. Only may, not this whole string, because it reads until it meets the white space. Because there is a white space here, cin stops reads here and store this may to this S1. And S2 receive value 2, the here, because after space, the next string is this one. And then it stops read here because there is a space. So S1 will be may and S2 will be the. So as you can see here, even though there is a white space here between may and the, with cin, you cannot store this white space. You cannot read this white space and store it into your variable. You must be careful about that. Let's look at this, more about this using the demo code in a later slide. So this is a similar example code. This code is from textbook explaining similar concepts. So this is very long. This outputs here ask for user to enter the age of the dog, and it reads the age using the cin object, and then it multiplied the age by 7 times, and then it asks user to enter dog name here, and then dog name, the input dog name will be read and stored into this dog name variable using this cin statements. And after that, this program prints out this string. So dog name will be print, and then this string, and then the age. So if we run this program, so how many years old your dog? This is this part is outputting here, and note that there is a no new line here. So that is the reason why user's input appears next to this cout result. So user entered 5. So 5 will be stored into this actual age variable, and then it asks user to enter dog name here. So it program prints here, and then user puts Rex here. So Rex will be stored in this variable. So note that there is a multiply by 7. So 5 times 7 is 35. So age is 35, and the dog name is Rex because we put the Rex here. So this is the expected result from the users. But if users entered the dog name like this, Mr. Bonjangles, and note that there is a space here. If your program like this, and if user enter this, age is 70, which is correct because 10 times 7 is 17. There is no problem with this, but the name of the dog is not expected result. So expected result is to print this whole string, but this program only prints to MR dots. It does not print this part. That's because scene reads the input data until it meets the white space. Because there is a white space here, it only reads this part, not this part. If the Bojangles string is ignored by this program, but would be read next if there was another scene statement. So if there is another scene statement below here and put variable, then the Bojangles, the string will be read in the next scene statements. So you must be careful that all white spaces, including blanks, tabs, and line breaks, are skipped when you use scene. And scene stops reading when it meets space, like this, or line breaks, new line. So